Okay, let's talk about geometric sequences. So a geometric sequence, for this to be true, or for a sequence to be geometric, if you take any term and divide it by the previous term, the answer is always the same. So for arithmetic sequences, if you subtract, you got the same answer. Subtracted, you got the same answer. For geometric, if you divide, you get the same answer. And this is called the constant ratio. And we call that R. So again, arithmetic sequences have a constant difference, and geometric sequences have a constant ratio. So let's determine if these sequences are geometric. So we will take -3 divided by -1, which is 3. -3 divided by 1, which is a -3. 9 divided by -3, which is -3. And -27 divided by 9, which is -3. So since those are all the same value, yes, it's geometric, and R equals -3. For the next one, 10 over 2 is 5. 50 divided by 10 is 5. 250 divided by 50 is 5. So yes, it's geometric, and R equals 5. So the formula for geometric sequences. So first of all, n is our term number, just like it was for arithmetic sequences, and R is our constant ratio. So then the explicit formula, G sub n. For arithmetic sequences, we usually say A sub n for arithmetic. Now we say G sub n for geometric, equals G1, which is our initial term, times our constant ratio to the n minus 1 power. Recursively, we always have to include the first term. G1 equals something, depending on the sequence. And then G sub n equals the previous term, G sub n minus 1, times R. So that's the recursive formula. These look pretty similar, very much similar to the arithmetic sequence formulas, but now we are multiplying instead of adding. So again, just to review a little bit, recursive formulas depend on the prior term. And explicit formulas you can use to find any term without needing to know any term except the first one. So first, for this first sequence, our first term is 3. Our common ratio, well, 9 over 3 is 3, 27 over 9 is 3, 81 over 27 is 3, so R is 3. Then recursively, G1, or the first term, is 3. Then G sub n is whatever the prior term is, G sub n minus 1, times 3. Explicit formula, well, G sub n, we start with our first term. This should be G, sorry about that, guys, which is 3, times our R, which is 3, to the power of n minus 1. Next one, this looks kind of weird, but it'll work the same. So if you do 4n divided by 2n, n over n is 1, 4 over 2 is 2. And then if we look at 6n over 4n, this one's actually kind of a trick, because this is 3 halves. So this is not geometric. Next one, negative 2 over 1 is negative 2. 4 over negative 2 is negative 2, negative 2, negative 2. So r is negative 2. First term is 1. Recursively, g sub 1 equals 1, and then g sub n is equal to the prior term, g sub n minus 1, times negative 2. Now our explicit formula, g sub n is our first term, which is 1, times our r, which is negative 2, to the power of n minus 1. Now we have some examples, and we'll actually calculate some terms. So first we have the sequence in number 5. I don't know if it's really numbered quite properly. Doesn't matter, we're calling it 5. Okay. Example 3, number 5, I suppose. We're not actually finding a sub 10 because we're seeing if it's geometric, so we'll find g10. So looking at this, negative 2 over negative 1 is 2. Negative 4 over negative 2 is also 2. And negative 8 over negative 4 is 2. So yes, it's geometric, and r equals 2. So then if we find the explicit formula, g sub n, well, what's our first term? Negative 1. So g sub n is negative 1 times our r, which is 2 to the power of n minus 1. Now our task is to find the 10th term. So g sub 10, negative 1 times 2, instead of n we'll put 10 minus 1. So this is, oops, sorry about that, negative 1 times 2 to the 9th, which is negative 1 times 512. So the 10th term, or g sub 10, equals negative 512. Now this other sequence, again, not A, let's do G. So G sub 12, and we'll switch colors, just because. So now, let's see, well, negative 12 divided by 4 equals negative 3. 36 divided by negative 12 is also negative 3. And negative 108 divided by 36 is negative 3. So again, the reason why this is geometric is because these are all the same. In this case, they're all negative 3. So yes, geometric, r equals negative 3. Our first term is 4, so our explicit formula, g sub n, equals g sub 1, which is 4, times r, which is negative 3, to the power of n minus 1. So now to find the 12th term, it's the second part of our task. G sub 12 equals 4 times negative 3, and now our n is 12, so 12 minus 1. So this is 4 times negative 3 to the 11th, which is 4 times negative 3 to the 11th. No, I don't just know this, I use my calculator. Negative 177,147. If you multiply that, our 12th term ends up being negative 708,580.